So this is part 3 video for integrals under kinematics, question number 35 onwards. The following diagram shows the graph of a quadratic function. Now in this quadratic function, what is being asked? Now the x-intercepts are -4 and 0, 6, 0, and y-intercept is 0, 240. So this is the x-intercept over here and over here. This is 6, 0 and -4, 0, and the y-intercept is 0, 240. Write down f of x in this form. So whenever we have what is this x-intercepts, those will be useful. Those will be the values of p and q. So what am I going to do that? So f of x equals to -10 x minus of minus p. This is p value and this is q value, and x minus 6. So what does that becomes now? It becomes -10 x plus 4 times x minus 6. Find another expression of f of x in this form. So this is called as vertex form. You have to get it out the vertex form. So what should I do it out? First of all, the vertex will be the midpoint of these two, what is this, intercepts. So x coordinate will be the midpoint. So -4 plus 6 upon 2, which is 2 upon 2, which is 1. So the h value is going to be 1. Now what am I going to do with that? I am going to get the k value. So we know that y equals to -10 x plus 4 times x minus 6. So substitute this x equals to 1 over there. So y equals to -10 1 plus 4 times 1 minus 6. So this gives me the y value as nothing but how much? 250. So the vertex is 1, 250. Once I know the vertex is 1, 250, f of x will become -10 x minus 1 whole square plus 250. That's going to be the answer. Show that f of x can also be written it out in this way. So that is for part C. So what is that? -10 times x plus 4 times x minus 6 is -10 x square minus 6x plus 4x minus 24. So it becomes 240 plus 20x minus 10x square. This is going to be the way how I get for part C. Now coming to part D, find the value of t. A particle moves along a straight line with a velocity v centimeters per second, and v is given by this one. Find the value of t when the speed of the particle is greatest. Speed of the particle will be greatest at the vertex, which is the vertex of parabola. Vertex of parabola v prime t should be equals to 0. So t equals to 1. V prime t should be equals to 0. Phrase that. What is this? I will be getting it out. T equals to 1. Or else I can write it out. What is v prime t? V prime t will be 20 minus 20t should be equals to 0. So 20 equals to 20t. So t equals to 1. Next part, find the acceleration of the particle when the velocity is 0. For part 2, acceleration is nothing but what? V prime t only is only the acceleration. So that should be equals to 0. The same thing, 20 minus 20t should be equals to 0. So speed should be, acceleration is equals to this much. Now what is he asking in acceleration? When the speed is 0, not acceleration is 0, the speed should be 0. So acceleration is this one. Now the speed should be 0. Speed, this is 20 minus 20t. Speed should be equals to 0. What is the formula for the speed? The speed formula was 240 plus 20t minus 10t square. 240 plus 20t minus 10t square. plus 20t minus 10t square. This should be equals to 0. By using the calculator, we'll be getting the value t equal to 6. So the acceleration at 6, substitute that one, 20 minus 20 times of 6, which is going to be negative 100 meter per second square. Now coming to question number 36. In this question, S represents the displacement in meters and T represents the time in seconds. The velocity v meters per second of a moving body is given. V equals to 40 minus 80, where A is a non-zero constant. If S equals to 100, when T equals to 0, find an expression for S in terms of A and T. So he has given the velocity. So in order to find distance, it is integral of velocity v dt. So which is integral of 40 minus 80 dt. So what does it S will become? 40t minus half 80 square plus c. Now we know that S equals to 100, t equals to 0. So 100 equals to 0 minus 0 plus c, which gives me c as 100. So what is the formula for S? I get it out, 40t minus half 80 square plus 100. Now part 2, S equals to 0, t equals to 0, find an expression in terms of A and T. So in that case, what I'll be getting it out? C will be equals to 0. So in that case, 40t minus half 80 square. Last time S was 100, so C was 100. This time S is 0, so C will become 0. So therefore, this becomes the equation. Next, train approaching a station to slow down when it passes through a point P. As the train slows down, its velocity is 40 minus 80. When t equals to 0, the train is at P. The station is 500 meters from P. A train M slows down so that it comes to a stop at the station. Find the time it takes train M to come to a stop, giving your answer in terms of A. So, for part B. Now, for part B, what am I going to do? It should stop at the station. What is the thing? The train should stop at the station. If at all it is stopping at the station, velocity should be equals to 0. So we know that 40 minus 80 should be equals to 0. That gives me the value of t as 40 upon A. Now we know the formula for the distance. What was the formula for the distance? It was 40t minus half 80 square. When S equals to 0, that was a condition. So I use that condition. So S equals to nothing but how much? 40 times t is what? 40 upon A minus half times A times 40 square upon A square. But the distance is nothing but how much? 500, because it is at a distance of 500 from the station. So one A and A gets cancelled. So what am I left over with? 1600 upon A minus 800 upon A equals to 500. So 800 upon A equals to 500. So A equals to 800 upon 500. So which is 8 upon 5. This is for part B2. And this is B1. Now finally part C. For a different train N, the A value is 4. Show that the train will stop before it reaches the station. This time A value is 4. For part C, we know that A value is 4. So velocity is nothing but 40 minus 80, but A value is 4, right? So 40 minus 4t. So t and velocity should be equals to 0 whenever it is stopping. So 40 minus 4t equals to 0. So t equals to 10 seconds. What is the distance it travels in 10 seconds? 40t minus half a t square, which is going to be 200. But actually the distance is nothing but how much? 500. So 200 is less than 500. So therefore train stops before the station. Train stops before station. Question number 37. Particle A moves in a straight line starting from O such that its velocity in meters per second is given. Particle B moves in a straight line such that its velocity is given. Find the maximum value of VA, justifying that it is maximum. Find the acceleration of B when t equals to 4. So for part A, maximum means dV by dt should be equals to 0. So I am finding it out dv by dt. So what does that becomes dv by dt? dv by dt becomes minus 1 upon 2, 2t plus 3 should be equals to 0. So t minus 3 equals to 0, t equals to 3. Now justify it as maximum. So for that I should be finding the second derivative d square v upon dt square, which is nothing but what? Negative 1. And it is always less than 0. So therefore it is going to be maximum. And what will be the maximum velocity? Substitute out over there. Max velocity will be minus 1 upon 2, t square is 3 square, plus 3 times 3 plus 3 by 2. What am I doing it at? I am substituting in this equation. So simplify that, you should be able to get 6 meters per second. Part A. Part B, find the acceleration of B when t equals to 4. So acceleration equals to nothing but what? dv upon dt, which is 1 upon 5 e per 0.2 t. Now substitute t equals to 4. So acceleration will become 0.445 meter per second square. Substitute t equals to 4 in this equation. Coming to part C. The displacements of A and B from OA and OB respectively at a time t are SA and SB. When t equals to 0, SA equals to 0 but SB equals to 5. Find an expression for SA and SB giving your answer in terms of t. So SA will be integral of VA dt, whereas SB will be integral of VB dt. So this will be integral, I am directly writing, you will be getting 1 by 6 t cube plus 3 upon 2 t square plus 3 upon 2 t plus c. But we know that t equals to 0, SA equals to 0, which gives me c equals to 0. So therefore the equation for SA will be negative 1 upon 6 t cube plus 3 upon 2 t square plus 3 upon 2 t. Whereas for SB, SB equals to integral of e power 0.2 t dt, which will become 5 e power 0.2 t plus some constant d. But he gave that t equals to 0, SB equals to 5. Plug in that 5 equals to 5 e power 0 plus d. So d equals to 0. So therefore what is the SB's equation? 5 e power 0.2 t. Lastly, part D, sketch the curves on the same diagram. Find the values of t where SA equals to SB. So what am I going to do? I am going to sketch the curves. So the first curve from the graphing calculator, it looks like this, and the other curve looks in this way. This is 5, 0, and t, and this is S, and 1, 2, 3, 4, 5, 6, and 5, 10, 15, and so on. This is going to be this one. Now, where do they intersect? Use the graphing calculator. You should be getting 1.95 and t equals to 7.81. And the last question, question number 38. The acceleration is given by this formula. Find the velocity at t equals to 3. In order to find the velocity, what am I supposed to do? Integration of the acceleration. So which is integral of minus 1 upon 1 plus t whole square dt, which is 1 upon 1 plus t plus c. He told that at t equals to 1, velocity is 8. There is a printing error over here. T equals to 1, velocity is 8. So t equals to 1, v equals to 8. So 1 upon 2 plus c equals to 8. This gives me c value 15 upon 2. So what is the equation of the velocity? I'll be getting it out. 1 upon 1 plus t plus 15 upon 2. Find the velocity when t equals to 3. So what am I going to do? Plug in t equals to 3. So velocity will be 1 upon 4 plus 15 upon 2, which is 31 upon 4 meters per second. Find the limit of t as velocity as t approaches infinity. So as t approaches infinity, 1 upon t plus 1 will be approaching 0. It becomes very much to 0. So I'll be left over only with 15 upon 2. So the velocity will be just only 15 upon 2 meters per second. Next part C. Lastly, part C, find the exact distance from t equals to 1 to 3. So distance equals to integral of v dt from 1 to 3. So integral of 1 upon 1 plus t plus 15 upon 2 dt from 1 to 3. So which is ln 1 plus t plus 15 upon 2t from 1 to 3. So what do I get it out? I'll be getting it out ln 4 plus 45 upon 2 minus ln 2 minus 15 upon 2. Simplify that, you should be getting ln 2 plus 15 meters. That's going to be the answer. So that completes the kinematics. See you in the next video. Bye.